Good afternoon, everybody, and welcome to today's TGI Kubernetes. Today we have a supply chain security inspired episode, still focused on Kubernetes, but all the exciting projects we have going on in this space. I've got a couple of great guests here with me today. We've got Matt and Scott. So welcome. I'll give you each a chance to do a quick introduction.
Okay, I am Scott Nichols, former VMware, new founder of ChainGuard. We're new startup trying to focus around supply chain security. And Matt?
Hi, I'm Matt, also formerly of VMware, before that Google, before that Microsoft, also one of the founders of ChainGuard, doing supply chain security stuff around projects like the ones we'll be talking today, SLSA, Sigstore, and a few others.
Cool. Well, it is a privilege and an honor to have you here. I don't think that Matt remembers the first conversation I had with him was we had an internal group talking about how to build containers. And this guy, Matt, who I'd never heard of before, started presenting. And he just starts, as he's going along, casually mentioning, there's this Co thing, and there's this GCR thing, and there's this Knative thing, and like all of these things. And he's like, and I started these, and I'm like, where did this guy come from? Why have I never heard of it? And it was mostly me being oblivious to all of the things Matt had done rather than the notoriety of it. But that was how I first met Matt. So I asked him some really basic questions, and now we're going to repeat that again today. I can ask him and Scott some super basic questions about supply chain security and everything else. So for all of you joining us, it's a weekly tradition to let us know where you're tuning in from. I see we've got some people from the Netherlands, people from Scottsdale, I'm assuming Arizona, Colombia. I am in, we've got chilly Northern California. I'm in chilly Minnesota, so it might be a little bit colder than Northern California, but it depends on your elevation, I guess. Germany, Brazil, it's awesome to see people tuning in all over, so. All right, with that, let's take a look at the week in review. So not a whole lot going on in the world of, let's see if we can show the notes here. In the world of Kubernetes, the other week 1.23 came out, and there'll be a TGIK on that first thing next year. The big thing on everybody's mind is the call for proposals for KubeCon EU closes tonight at the second before midnight Pacific time. So if you haven't got your CFP in yet, everybody is looking for a company-sponsored trip to Valencia, Spain. So definitely get those proposals in. Also have a link for an article in here, kind of walking through some of the cool new dual stack stuff if you want to be able to connect to services in AWS using IPv4 and or IPv6. There's a little bit of extra to go through there. And then Log4j. Everybody's heard about this, probably. Sneak put together this really awesome GitHub repo with a ton of sources on this. There's information about explanations, what does it mean, what software is vulnerable, Twitter discussions, memes. That's one of the most important parts, all of the Log4j memes that are out there, and a bunch of really cool links and resources here. So Scott or Matt, anything else to add about Log4j?
I'm just glad that I dodged it by not hosting too much in Java, but it's been pretty. I don't know. I've been calling it the worst vulnerability that we've seen, in recent memory for sure. But like, it just seems so exploitable, and it's pretty remarkable, right? That it's been there for so long and affects so many things that it's hard to fathom.
Does anyone know if the other Log4j clones adopted that same kind of pattern? Because I know there's like log for other things.
Yeah, I don't know. Anybody in the chat, feel free to help us out if you know. I know a big part of the debate I've seen as far as like the severity of the vulnerability. People are talking about like how bad the code is or the problem is versus how easy it is to exploit, and that's a big part of it, right? It's like you look at the conversation about the Intel chips, the vulnerabilities there, right? What was that one called? The
Rowhammer?
I'm trying to.
You think you've like the Rowhammer ones, the ones that were like.
They were like in the microarchitecture of the chips themselves. And it's like you can't, unless you make a new chip, you're not going to fix that, right? but in order to exploit the vulnerability in the chip itself, you have to really know what you're doing down to like the assembly level or something like that. Whereas like this, the people making QR codes and putting them all over the place so that when some kind of photo recognition thing picks up on it, they will get owned by a QR code. So it is fascinating. And Dan had a great meme of it's the worst one yet, the worst vulnerability so far. But I think the other thing that is super interesting is this is almost exactly a year after SolarWinds, right? So I think we've really been thinking a lot more closely about this over the course of last year, and then to just see this is one more thing. There will be something else tomorrow. There will be another thing, and that's the way this goes. But
yeah.
Yeah.
So like one of the next ones that's on here, right? Like it's been sort of the last few days, scary vulnerabilities, right? Like the log4j, log4j, however you pronounce it. I'm going to say 4j. That's scary in terms of the breadth. And then this next one, right? Like the NSO Pegasus zero-click vulnerability, right? That's scaring people in just like a whole new dimension in terms of how sophisticated the attack is and how, short of like putting your mobile device in a, Faraday cage forever and never turning it on, you're not gonna, avoid getting exploited by those kinds of like super sophisticated attacks. It's super scary.
Well, I think it's not an exploit per se, but my favorite vulnerability in this kind of realm was I think Samsung phones had a QR code that would factory reset them. And somebody started printing those out and sticking them in the New York subway, like on posters. Because like you walk up to the poster, and you're like, interesting, I want to watch that movie trailer. Scan the QR code. And for a lot of people, it just opened a garbage page. But for those special Samsung devices, insta wipe. No checking, no anything. Just your phone is gone.
That sounds terrible. So backups, that's the other important part. Backup everything.
Test your backups.
Yeah, your backups are useless if they can't be recovered. Another interesting news in the scope of supply chain security, OpenSSF. We'll talk a little bit more about that group, the Open Source Security Foundation. Anchor is proposing to donate SIFT and Gripe, which are a really cool set of technologies that we talk about a lot in the Project Sigstore Slack, because they've decoupled and separated out some of the concerns of generating a bill of materials versus leveraging that bill of materials to actually detect and find vulnerabilities. And so they're proposing to donate those. And I think that'd be a really great addition to the emerging ecosystem that's really blossoming inside of the Open Source Security Foundation. And Sigstore recently also moved into OpenSSF, which is a really great home for the project. And then Cosign, we've got a new release. Let's look at all of the cool new features in here. A whole bunch of bug fixes. I think 1.4, well, let me go back to that. I had more of the, there we go. breaking Cosign experimental. This and all future Cosign releases will generate signatures that do not validate in the older version. So I think this is about being able to get the keyless out of experimental mode, right? We want to kind of move past that and be able to use it by, I don't know if by default is the right way to phrase it, but at least use it without experimental flags. And some other piv key stuff, which is if you want to use YubiKeys or other things like that for signing. And releases are now additionally signed using the keyless flow. So it's cool to see a cosign being signed by Cosign. Anything else that I'm missing from the release notes?
So I guess one other thing that we can call out, it's not, I don't know whether this was called out on a previous TGIK, but it's related to Cosign and whatnot, so it's probably worth shouting out here anyways. In the last, I think this was like 2, maybe 3 weeks ago now, sense of time has distorted a bit, the GitHub Actions starter workflow for container builds landed support for Cosign keyless signing by default. So GitHub Actions launched this support for producing identity tokens for the workflow that you run as. And this works for merge requests, cron, as well as workflow dispatch and a bunch of them. It doesn't work with PR flows because you don't want to hand out credentials to PR flows, but for other flows, you can generate identity tokens, and then you can use those identity tokens as part of this keyless flow with Project Sigstore to sign things. And so the starter action for container images that does a build and push of a container image for your GitHub repo now supports, has the identity token permission and will sign things with Cosign after it's published the image, which is super cool because now, when you start to use containers with GitHub Actions, you're set up to also start signing those with information about, which GitHub workflow produced that container image. So, and one of the things that landed in 1.4 in support of that was before we had this prompt that, like, if one of the aspects of doing keyless signing is publishing information to a transparency log so that you can audit, who's signing what as different identities. And by default, Cosign will not publish to that transparency log, which is public, for private images. And so, but it would prompt you if it detected the image was private before it published there. And in keyless flows where you're running as part of a workload, obviously it's not a TTY, so it's, gets an EOF immediately. And so it was, Cosign was panicking prior to 1.4. So we couldn't sort of enable this keyless signing flow for private repos in the starter workflow before for GitHub Actions. But now that 1.4 is out and fixes that, the starter workflow for private images will start to sign things, which is great. And you can have even private repos published to the transparency log if you're okay with the hash of your image leaking out by passing the force flag, or you can leave that off and not publish to the transparency log. But then public images will do the keyless signing and publish to the transparency log by default. So, so that's one of the things that's landed recently, and folks should check it out. It's awesome. And I don't know, maybe we'll play with an example of that today.
Cool. So much exciting stuff, and it's moving so quickly. Another part of exciting stuff is Artifact Hub and a lot of the work I think is that Andrew is doing around Helm charts and being able to sign those, especially the OCI version of Helm charts or OCI repos for Helm charts. I mean, when you talk about prevalence of Kubernetes software that's out there, it's Helm charts far and away, I think, are probably the most common thing. If anybody has statistics on that, I'd love to see it. It's one of these questions we're always looking for in terms of what's really being used out there. And I think Helm charts are super popular. And then I think Matt added another KEP for release artifact signing.
Yeah, so I think that just merged today. But yeah, the KEP 3031 to start signing release artifacts, I believe with Cosign, is got merged. So yay, we'll start getting signed release artifacts out of Kubernetes.
Yeah, that's cool.
Yeah, one of the things we talk about a lot is always secure by default, right? And when can we have something that's going to force signature verification enabled by default when you start up a K8s cluster or anything else, right? And until Kubernetes itself is signed, it's going to be awfully difficult to do that. So that'll be really helpful.
So there's a question in chat. What about private attestations? I guess that's not advised. So that's a good question. Right now, the starter workflow isn't doing any sort of attestation. It's also not doing anything with SBOMs, which is another thing that it could potentially look at. Let's see. So Cosign attest. Yeah. So for folks that aren't familiar, there's sort of layers to what you really want to use signing for, right? So in the simplest sense, signing is a way of sort of saying, I produced this thing, right? And so a form of it that people are really familiar with is, well, probably developers are somewhat familiar with, are things like git commit signing, which the person who signed that commit, is sort of saying, I produced this. And if you can verify their identity with the key system, then you can authenticate that person actually signed that commit. So that's one of the things that like the verified box on GitHub keys off of and things like that. Attestations. So signing things isn't the goal, right? The goal is to enable. It's signing sort of like authentication, and what do you want to use that authentication for, right? You want to use that authentication to authenticate, making claims about a thing, right? I produce this, which is the sort of naked signature use case, is probably the simplest thing, but really, like, say Scott's producing something, but I want to say something about it, right? So an example to extend the sort of git commit signing metaphor, right? I, as the author, can sign the commit and I can push it. There aren't really mechanisms in Git today for me as the reviewer of, say, Scott's PR to sign metadata saying I approve of this, right? That's something that systems like GitHub layer on top of it. And there aren't really ways for systems to sort of attach information to, at least not well standardized ways of attaching metadata to commits that are signed by identities other than the commit author. And so this is where attestations sort of come in, right? So attestations are a way of building on top of the idea of signing to make claims about things. And so, let's see. So back to the question about Cosign attest and the transparency log stuff. I would say, the bits about sort of what's uploaded to the transparency log and whatnot, I think are pretty similar between whether you're signing the claim or signing the image. I don't think, although I haven't looked too deeply, I don't think any additional information would be leaked to the transparency log with the Cosign attest flow, but I could be mistaken there. So I think that it would be, similar circumstances to publishing the image. You wouldn't want your sort of image hash or whatever to leak. So hopefully that answers the question, as well as gives some insight into sort of, I think, where we sort of want to head with this idea of making signing really easy, right? Signing's not the end game. Right.
Yeah, a lot to dig into there. And I think there's a lot of different ways to attest to things, and a lot of different meanings people can assign to attestations. So we try and take a look at some of those things as we start getting into the live action and the demo stuff. So one of the other things you'll hear us chat about today is SLSA and Operation SLSA, a really awesome set of YouTube videos. Part 2 is coming soon. I'm not going to open the links for these. I promise they're not Rickroll videos, but you can also just Google Operation SLSA. And aligned with that, we've got a brand new SLSA website. So SLSA is, what is SLSA? Supply chain levels for software artifacts. There's some really good videos about this from the Supply Chain Security Con as well that happened at the last co-located event with the last KubeCon, where I think Priya and some other folks go through all of the things that we're working on here. The big thing is you look at the supply chain problem, you basically have the high-level steps, and not only are the steps themselves vulnerable to compromise, every link in between the steps is vulnerable to compromise. And so with SLSA, you can build up different levels of assurance. And so kind of starting with level 1, 2, 3, 4. I haven't gone through all the stuff on this new website, but already looking at it, it looks awesome. So and then there's specifications for each level, which go from no guarantees, very low level, to eventually level 4 is going to be super strict and potentially impossible today to actually achieve, depending on who you talk to and how you interpret it. However, I know we've been working on the supply chain security reference architecture in the CNCF 6 security working group for that. In between the time we started the reference architecture and the review version that is right now, new tools have been created that didn't even exist when we started it. So whether or not you can achieve SLSA 4 today doesn't really matter, because by tomorrow the answer will be different, and we'll get closer and closer to being yes for every opinion as time goes on. So. And the other important part, I think, about SLSA is not just that there's this idea out there and there's this thing that people are talking about, but we're actually seeing different really important infrastructure projects to talking about adopting SLSA as a standard for how to communicate to the consumers of their software that it is secure. And so Kubernetes itself and K3S as well are looking at proposals to become SLSA compliant at different levels. And if anybody out there is thinking about doing this, I know there's a lot of people who are interested in helping you out. And there's on the SLSA dev website, there's information about how to connect with the community there. The starting point of level 1 offers a whole bunch of assurances that you should be able to do, and that's a great place to start. So you definitely should not be afraid to start there if it's something you want to do.
Gotta start somewhere.
Yeah.
And if folks are interested in learning more about that, or bandwidth permitting, getting some help on some of the early steps there, definitely reach out. If you're involved in an open source project that wants to improve its its SLSA level, we can hopefully point you at resources or potentially help a bit there. So folks, reach out and we can try to give you pointers to people and resources and stuff like that.
Cool. All right. So that's all the news we have for the week. A lot of news, a lot of exciting stuff in the supply chain security space. And pretty much everything we talked about is related to containers, which is, and I think Kubernetes as well. So that's one of the things. It's like the intersection and the overlap of where this space is improving, I think is heavily aligned with Kubernetes and containers. But there's still a lot of workloads out there that are not on Ks or containers, and that's part of the reason why maybe we get into a little bit. Now we finally got to the agenda. What is Sigstore? I think one of the things that's important to like recognize is Sigstore. Whoa, this is not the right link, but sigstore.dev, we'll update that, is not part of CNCF, which is, I think, an important thing to understand in terms of really they want to be, as it says right here, a big letter, new standard for signing, verifying, and protecting software. It doesn't have to be containerized software. It doesn't have to be software that only runs on Kubernetes. Software, even like we can talk about that, right? Like we're talking about the code of software potentially being able to sign commits, being able to sign the artifacts that are produced and built, being able to sign different stages throughout there. So
yeah, really, it's all about making signing easy, and we're talking to folks, who are interested in extending. We're coming from the cloud native space, so we have our own biases towards containers and stuff like that. I am a super nerd when it comes to things like containers, and I try to keep it secret from folks like John, so that they. But we've got folks who are looking at pick a package management system, and there are folks who are looking at how to integrate Sigstore signing into those systems and make it really as easy as I think we've tried to make it for container images. So yeah, it's definitely not just about containers.
I think like at a high level, all of this stuff is really about adding observability to all the pre-prod pieces, and we don't really have that today.
Yeah, sort of a traceability or whatnot, right? Like to it's like supply chain traceability and observability as opposed to like what you conventionally think of like observability of the system, right? If the system is your supply chain, I guess to some extent it's sort of like observability there, right?
Yeah, and I think another important part to call out here, looking at the, in collaboration with section here, we've got a really, I think, good list of companies that are involved. I think we're all on the call biased here because we are part of company. We think this is really important, and I think there's seeing besides just the folks representing on this TGIK, Google and Red Hat and universities involved, the Linux Foundation itself, HPE, Cisco. It's really important to have this broad industry-wide recognition that this is a great way of solving this problem. And then more importantly than that, looking at 465 plus members, 20 plus organizations. Not everybody has the money to sponsor this, but there's a ton of people participating and getting involved in the Sigstore Slack every day. I see a message from someone new, from some company that I never even knew was using any of the Sigstore technology, post a link to their company's GitHub repo or something else where they're using Cosign or Fulcio or Rekor in different ways. So that's really, really cool to see. So we can kind of see, I think we talked about a lot of the stuff here. And one of the things, we'll talk about why Sigstore and what makes Sigstore different. I think this is where we kind of get into a little bit automatic key management, the transparent ledger. So that I think these are pretty much references to Fulcio and Rekor, and we'll dive into those projects specifically. But maybe Matt or Scott, anything in particular to you that, signing is not a new thing. We had Notary, we've had V1, we've got other proposals out there as well. We have GPG for a long time, right? And they have not been widely adopted. They're not widely used. It's not really like we didn't invent new versions of cryptography or new math or anything else to sign this stuff. So what is being done that's different that makes this that makes Sigstore matter.
Yeah. So I've been talking a lot. I don't know if Scott wants to talk.
The short version is so Sigstore is trying to do what Let's Encrypt did for HTTPS, right? You could get a cert 5 years ago, but it involved like emailing somebody your credit card number and then like getting the cert back in your email and then like uploading that to your website or whatever, and then hope that you remember to do that whole thing in a year when it expires. And so as a result, only a handful of websites were secured, and Let's Encrypt came along and said, you know what, let's make it super easy and a public service to go get a certificate to encrypt your website. And as a result, like 95% of the web is now HTTPS, right? And in fact, like Chrome makes you jump through hoops to visit a non-HTTPS site. And so I think Sigstore is attempting to do that same level of difficulty for container signing or artifact signing or blob signing because it's too hard today, right? Let's Encrypt didn't invent anything new. They just assembled the pieces to make it, right, sorry. They invented the very little, right? Like they didn't rediscover encryption or certificates. They just exposed it in a way that's friendly for website developers. And so Sigstore is doing the same thing, but for signing.
Yeah, so I mean, I think the two key things, right, are it was hard and it was expensive to do things with TLS before Let's Encrypt, and now it's easy and free, which is hard to compete with that, right? And so I think signing is sort of in that same sort of state today, where dealing with signing keys is harder than it should be, and the systems that manage those keys are often very, very expensive. So, the things like fulcio and whatnot are trying to do that, what Let's Encrypt did, and make it easy and free, or as close to free as we can make it, for the sort of public good instance, to get folks signing things. Because in the container space, like what percent? I mean, I think it's probably even worse than HTTPS on the web in terms of folks actually signing things. Since I mentioned integrating with different packaging systems. Some packaging systems don't even have a mechanism for signing things, right? And so some of those conversations are, how do we build a signing mechanism into our packaging system so that we can adopt Sigstore and the related technologies. So yeah, I mean. I think we're even in an even worse state than the web was before Let's Encrypt with respect to packaging systems. But there's a lot of things. So when I was making gestures at Scott when he said Let's Encrypt didn't invent anything, I think from a sort of PKI perspective, public key infrastructure, Let's Encrypt didn't no new cryptography and whatnot, as John was saying. One of the things that did come out of that is this idea of a challenge process that can be used to automate certificate issuance, right? And so, Let's Encrypt has the Acme challenge system, where you use like an HTTP challenge, an HTTP01 or a DNS01 or an ALPN01 challenge to, satisfy, proving that you own the domain that you're asking for a cert for. And depending on the type of challenge, you can get different types of certificates out of it, right? So this is one of the places that fulcio, is learning a lot from what Let's Encrypt did. And there's an identity challenge process that you go through with fulcio to prove you are who you say you are, and then you get your key is linked into a certificate chain to a root. So again, no new sort of PKI here, right? It's still, key pairs. I think the idea of certificate chains being involved in signing is relatively new to the context of signing, but it's all a very, well understood, thing, because it's how the web has been built for forever, right? I mean, it's been around. And it's a very sort of well-exercised technology. So, So yeah, it's building on some of those ideas.
Cool. Yeah, and I think there's some great diagrams and things to walk through here, and you can see the different flows and the root of trust. We'll maybe talk a little bit more about that when we get to looking at fulcio. But maybe now let's just double check. I think let's go ahead and try and sign something. See what we can do. So the first thing we should do is if I look, I do not have Cosign, so I need to securely get. I'm going to make sure I securely get Cosign if I'm going to get something that's going to sign all of my container images. What's the best way to go and get it?
Easy.
Should I just brew install Cosign?
Sudo curl.
Yeah, curl pipe bash. What is the GitHub is always the most secure place to get stuff right. Sigstore, Cosign. And do I just download a release? Does it give me?
I think it's in brew as well.
Yeah, I think there's a brew package.
All right.
Yeah.
Let's see if brew works on this machine. One thing I didn't mention that I should have is I am in management. So as an engineering manager, nothing on my laptop may work. We'll see what happens. I do have Minikube running, so I at least figured out some mechanism for getting Kubernetes installed. I have brew. It's updating homebrew. Maybe I should have done that before while we were waiting, but. We will see what happens here.
Yeah, I pulled up the install docs. It looks like brew install Cosign should work.
Yeah.
Here, I'll add that to resources.
Even works on Apple Silicon.
Nice. All right, so now we have a Cosign, and how do I know this is the right Cosign? Is there a way to verify?
Say Cosign version. Well, I mean, I don't know what checking brew does off the top of my head. But, brew may have done some checks on validation.
All right. So we'll assume brew is trustworthy. Is that the assumption we make?
It might be as good as you're going to get right now. I don't know if they've started signing with Cosign, but they could, because I heard they moved a lot of their build packages to GHCR. So they're using OCI to store a lot of things that aren't necessarily containers, which is cool. But given Cosign's strong support for OCI, so yeah, you should be able to check that Git commit matches the 1.4.1 release tag. It's not going to tell you whether the binary is lying to you, but you could probably also the match.
There's that yeah, F0A3, F0B looks good. So
you can also try and verify the checksum against whatever your platform architecture are from the release page. I'm guessing there are some checksums on there, but I haven't looked, so let's see.
All right, so assuming we've got a good version of Cosign.
Yeah, there's also signatures for a lot of this stuff on that get uploaded as well. I'm just looking at the mountain of things that we attach to releases. It's quite large.
There was a large number of.
It looks like it's all about SIGs. So speaking of like non-OCI things, so Go Releaser in one of their most recent hot off the press releases had support for doing keyless signing as part of releasing Go binaries, right? So I think that may be part of what sorry, I'm reading the comments in chat. Yeah, so Go Releaser added support for signing as part of the Go release process. we tried to get GitHub to add a starter workflow for that, but unfortunately they aren't accepting new like CI starter workflows at the moment. So hopefully we can, convince them at some point. But unfortunately we couldn't do that. But yeah, check out the Go releaser support for Cosign as well. If you're just releasing Go binaries, I think that may be what we're using here for the Cosign releases. So.
Cool. Yeah. Somebody said Cosign, verify Cosign would work, and I think I'm missing key.
So let's see. So there's now. So Cosign verify is expecting a container image name. So if you let's see. So there's container images that are published as well. That should be on the install docs. Somewhere. Yeah, okay. So gcr.io project Sigstore Cosign is where images are, the actual release images are. So you can say, so Cosign verify, if you say gcr.io/project Sigstore, let me just make sure that's right. Yeah, project Sigstore, all lowercase, no punctuation, and then /Cosign. And then, there's a couple more things. So, this is going to do the keyless verification. So for right now, you need to set the Cosign experimental environment variable to 1 or true. So if you just all caps Cosign underscore.
Is there an underscore?
Yeah. Looks right, equals true. So that should work. You can add :v1.4.1, and that will do a keyless verification of the. There you go. So you can pipe this to JQ as well. If you have JQ installed, just pipe JQ dot. It gives it a bit more pleasant, so you can see some cool metadata down at the bottom. So this is who signed this. You can see the issuer was accounts.google.com. So this is a Google identity that signed it, and the subject is keyless at projectsigstore.iam.gserviceaccount.com. So for folks who aren't familiar with how Google service accounts work, IAM service accounts, the project Sigstore in the sort of domain part of that email like thing is the project ID, which is the same project ID that we have in the container image URI. And then the name of the service account within that project is keyless. I believe this is using Google Cloud Build to produce the releases. So it's using those to impersonate this service account and do the keyless signing flow, which is similar to if you were to do the same thing with, say, one of the distrolist images. So gcr.io /distrolist/static. I think you would see keyless at distrolist. So it's naming convention. It's nothing, official or anything, but those are sort of the identities we've adopted for doing some of this keyless signing for the things that are going through Google Cloud Build.
Cool. So now we have Cosign. We're fairly certain we've got a good version, and then there's I'm assuming a whole bunch of commands. Good grief. There's a few more commands than the last time I ran this. We've got attach, attest, clean, completion, copy, Docker file, download, generate key pair, help. I'm assuming that's more or less what this is. Yeah. Initialize, load, manifest, so many things. I think though, and maybe I don't know if either of you want to point to like a starting doc. I think we have to generate a key before we can sign anything, right?
Yeah. So I'd say let's start with generate key pair, which is that'll put us in the world of what most folks are, maybe doing today. If they're doing signing, this will generate a key pair locally that we can use. So it spits out two files, cosign.key and cosign.pub. Key is the private key, so it's what you'd use for signing, and cosign.pub is the public key, so it's what you might check into the root of your GitHub repo. Don't check in the .key file. That's bad. Bad. Slap your hands for that.
Well, this one's burnt now.
We will, yeah.
But, well, yeah, okay. Well, you can check this in, John. This is great. So we can use this to do some signing, and then verify it. So if you have an image you want to, do you have a container registry set up that we can play around with this with?
I do, yeah. We can, let's see here. Let's just use something. What do we got in here? Docker images. Let's just get everybody's favorite small image, it's Alpine, right? And let me see if I've got, make sure this registry works.
At least it's a nice short name. It always gets me. I mean, the ECR repo URLs are always the one where I'm like, I got to go look it up and copy and paste it because I'm never going to.
Well, we got keychain.
You don't remember 3 GUIDs together?
This is how you can tell I've been in management for too long. I'm getting props for keychain. We pushed something to the registry. All right, so our registry works. We've got an image there. Do we need the image in the registry before we sign it?
So that's a good question. You don't actually need, so it's sort of a subtle thing. So the image doesn't actually have to exist in the registry to sign it. And there's a mode in Cosign where, so if you set the Cosign repository environment variable, you can actually have your images exist in one place, and you could say sign that thing. But if you set the Cosign repository environment variable, you can redirect where all of the things that Cosign would sort of attach to that image to a different repo. So if you were to, for instance, if you wanted to cosign out the official Alpine image, you could do that. You just don't have access to push to Docker Hub, right? So you could actually redirect it to, you could say cosign repository, some other Docker repo name, and it would publish the .sig and .at and .sbom things there. So you technically don't need to copy it as you just did, but I think it's exactly where folks will start. So this sort of repo splitting is a more advanced use case. So this is a good first thing to show. So there's been some chatter in chat. I just want to make sure you do that.
Yeah, some questions about KMS systems and.
Yeah. So the generate key pair thing, and having the key and the public and private key on disk, that's just sort of the sort of kicking the tires example. There's a whole spectrum of different options. So you can use key references that are both files locally that are generated with generate key pair. There's also sort of a URI-based scheme where you can point at different KMS systems or even a Kubernetes secret to use keys from different KMS systems. I think GCP KMS, AWS KMS, Azure KMS are all supported. Kubernetes secrets are supported. I don't know whether or not Vault's supported, but I would guess it probably is. There's also some support for different hardware signing options in there. John mentioned before the PIV key stuff. So you can use some of those mechanisms as well. And then in addition to those, there's the key list stuff, which I'm super excited about that stuff because it's so easy. But yeah, there are support for a variety of KMS systems in Cosign. And if you have issues, file an issue or reach out on Slack. Pretty active on Slack.
Yes, so one of the things I noticed you mentioned there was as long as the key was generated by Cosign, generate key pair.
Oh, no, I don't think that's necessarily true. I don't think it has to be generated by Cosign, but I am not sure exactly what whether there are constraints around the types of keys it supports or anything like that. I believe it supports, the most common kinds, like, I can never remember all of the little acronyms, ECDS and
yeah, it supports
RSA.
a lot, but not all of them.
Yeah.
Okay.
Yeah. So I would certainly say try it. And if one's missing, like, I don't think it's that bad to add them, but famous last words. It's worth at least filing an issue, and we can try it.
So Vault is supported.
Awesome.
Nice.
Yeah,
and I did see part of the reason, besides burning myself, is that actually says begin encrypted Cosign private key. So that's the specific thing that gets generated by the Cosign generate key pair does say Cosign. So.
I don't think we actually use those for any sort of semantic purpose or require it to be a Cosign key. That's just how the pen encoded thing shows up. So hang on to that digest before you clear the screen or anything, because I'm a stickler for signing digests, not tags. We should definitely not just sign the tag. We should sign the digest we pushed. But yeah, so you should be able to pass the key in with --key. And then here you would put cosign.key. So this is one of the places you can use one of the sort of URI-ish things. I think you can say something like GCP KMS : // and then there's a mechanism for referencing a key within GCP KMS. Similarly, you can say Kate's : / namespace / secret name, and it can use that as either a signing key if the private bits are there, as well as a verification key if the public key is there. And it could just be the public key, and you could just use that for verification. But yeah, so now you want to, so you can copy the tag you push up above. We need the tag bit first. So dev blah 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 blah, and then throw that SHA at the end. All right. Yeah. So, all right. So yeah, you got to enter this, and now. Yeah, so now push the signature to that. So do you happen to have Crane installed? Probably not. We can. So you can say, yeah, okay. Don't worry about it.
No,
so
get Crane.
Okay, Crane. Yeah, Crane. So there's a library that a bunch of these tools build on called. We call it GGCR for short, but github.com/google/go-container registry. It's really a sort of an SDK for interacting with OCI images. And, while we were building it, we were like, well, we don't want to have to write code to use all this cool stuff. And so I don't remember whether it was Jason or John was like, we're going to write, a CLI that just tries to harness some of this functionality. And it's grown over time. But and there you go. It's even in Brew.
Yeah.
So you can say Crane ls and then that repo name. And yeah, there we go. So it basically tries to be a bit of a registry CLI for things that don't have it. So, okay, so ls uses the tags list endpoint, and you can see we pushed the latest tag up above. And then when we signed it, basically the way Cosign works today to maximize its compatibility with existing registries is it pushes a little, OCI thing alongside the image that encodes in the tag name the hash of the image it's signing. So if you were to say Crane Digest on that same reference you have above, so that E7 blah blah blah, that's exactly the digest of the image we just pushed. So the name of the tag sort of captures that. That's also encoded in the actual signature. So it's we aren't relying on that for semantic purposes. We're relying on that mostly as a convention for discovery. There's some work in OCI to try and extend OCI to support what's called references. That's been sort of a long process getting there, but I think the working group for that is starting to get organized, and that will hopefully allow us to move away from these sort of conventions to something that's sort of more first class within OCI. But having done this for a long time, I started the GCR team at Google, and so we've been doing this since V1 of the registry scheme. And every time a new thing came out, it was years before it was really pervasive, right? So V2 of the registry, it took a very long time before V1 was finally widely supported and shut off. And then there was Schema 1 to Schema 2, which is a whole nother thing. And OCI is based on that sort of Schema 2 thing. And it took really years before all of the different registries supported that Schema 2. So yeah, it takes a while for some of these things to roll out. So what Cosign's doing today is very pragmatic, like, okay, it works with basically every single registry. I think it works with every registry I'm aware of, with I think the exception of Quay. The open source Quay, I think, has support for it with the latest release, but I think the hosted Quay key, it's another one. I'm just going to pronounce it wrong, and you can make fun of me on Twitter.
I say Quay.
So yeah, Quay, the hosted Quay, I think, is a little bit behind. So I don't think it supports it, but yeah.
Yeah, I think I was looking at the OCI spec. The spec itself for container images in the last release was in 2017. So it's definitely, yeah, it moves at a different pace. But also the implications are huge, right? The consequences of all the software in containers that exist today. We talked a little bit about how not all software is containers, but there is a lot of software that, how many years ago did GCR start?
So I started GCR, let's see, we started that team right when I came back from paternity leave, and my daughter's turning 8 in January. So it'll be 8, well, the team will be 8 in, I think, May. GCR would launch privately sort of towards the end of that year, and publicly betaed early the following year. So early 2015 is when I think GCR went publicly beta. Yeah,
that's a lot of time for people to make container images in specific formats, and a lot to consider backwards compatibility and things like that moving forward. So,
well, and I mean, V1 of the registry didn't support content addressability, so there were no digests, which pains me, because there are things, I think there's debt in Kubernetes and some other places that probably wouldn't have been introduced the way it was introduced if there were proper digest support in the early registry stuff, and it took long enough to add that some of that stuff sort of baked in. But yeah, I lost my train of thought. But the content addressability, one of the fun things about that is it makes sort of automatically migrating to newer formats hard, if not impossible, right? So V1 images, we could roll forward to V2 because like people couldn't use a digest to pull V1 images. And so even if we changed it under the hood, which, we didn't actually change how we were storing it in GCR. We just had a smart serving layer that would serve it as V2 if you wanted V2. If you're pulling by digest, we can't change what we're serving you, right? We have to serve you exactly what that digest, represents. That's the nature of content addressability. So it will affect the ability to actually, upgrade in maybe not a great way. It's good for a legacy standpoint and backwards compatibility standpoint. But images reference schema 1 images referenced by digest, right, are going to be schema 1, until the heat death of the universe, well, or until someone breaks SHA-256. But yeah, so those are there to stay, and we can't silently migrate those forward. And so it'll have to be sort of a decision in clients like Containerd and whatnot when to drop support for some of those older image formats and things like that.
Sorry.
All right, so now we have something. We've got it signed.
Should
be able to verify it. Yes.
Yeah.
We probably don't want to verify with the private key. Do we need to pass in the public key though? Probably would make sense. Is it also just -- key?
Yeah, -- key, cosign.pub, and that. There you go.
Cosign claims were validated, signatures were verified against the public key, and the certificates were verified against the fulcio roots, which...
yeah, it's funny that it prints that, but it did not verify things against fulcio root. Yeah, well, that looks like a bug. Yeah, and we weren't using the fulcio root, so... but we should use the fulcio root. Let's use the fulcio root.
Yeah, let's do that instead. Now that I can't use this private key anymore, right? Because I printed it out. How are we going to sign this thing? All we need is cosign experimental.
Yep. Yeah. So basically, what this is going to do when you run it is it's going to generate a key pair in memory. And then, as you can see, it popped up in a browser window. This is sending John through a 3LO with, there's a few identity providers that are supported. So you pick one of the identity providers, and if you go back to your browser. So this is prompting you, so you can pick yes or no here. So basically, let's walk through what's happened so far. So Cosign generated, you can see generating ephemeral keys there at the top of the output. So it generated the ephemeral key, and then it basically wants to take those keys and sign it into a certificate chain that's rooted at the fulcio root. So it sent John through what I've been calling an identity challenge, right? To prove that John is who John says he is and not just a deep fake, it's secretly Joe Beta. And so now Fulcio knows that John is John and takes that ephemeral key pair and basically signs it and gives a certificate that it includes a bunch of metadata that we'll poke at for a second. But now using that key pair, you can sign the information or the image, and it can be verified even without that. Yeah, so this bit that it's prompting you about now is, since it's a private image, the dev.registry.pivotal.io is not a public registry, so it's asking you whether you want to publish the signing about it to the public transparency log. I'm pretty sure YouTube counts as another form of public log, so we're probably not leaking anything. aside from your private key. But so yeah, it's probably safe to publish that there. And you can see a tlog entry created with index. Now what we can do is we can do that same thing, but with verify and no key. And you may want to pipe this into JQ as well. So this is super interesting. So I guess we already saw an example of the keyless flow before, where it was being signed with Google Service Account identity. You can see the information about what's signed. The Docker reference is the repo name. The Docker manifest digest is the digest we signed. I'm not sure type ever changes.
I think the thing that's interesting about this is, just like Let's Encrypt made HTTPS available on the web. Before that, maybe if you found a website that was HTTPS, you could kind of trust it a bit better about its legitimacy. But now I can make a fake, bonk, usbonk.com, and I could get a cert for it, and I could trick you into like trying to log into something, right? If we're doing keyless signing here, not only do I trust that the signature came from the keyless root, but there's also this identity attached, and the identity now becomes the thing that we're looking at, rather than in the previous example, you're validating against a public cert, assuming that the private key is private. And so that you kind of have to establish that piece of trust, but there's not necessarily identity attached to it. You could attach identity, but by default, it's not there. But this one gets identity and the signature attached, but you can't necessarily trust the root in that anyone can use that same root if they use this tool, but they can't attach your identity to it. So that's kind of what Matt was talking about, where you have to do the identity flow to validate who you are.
Yeah, so there's a few different sort of points to make about this. One of the questions in chat was about, as the browser challenge one time, we're going to be used to sign things as John. It's a one-time challenge flow. It's not doing a sort of refresh flow or anything like that. So each time we sign it, it would send humans through the that 3LO flow. And one other important aspect is the key pair that is generated, the ephemeral keys that we saw it generating. Those live for some very short amount of time. It's like 10, 15 minutes maybe.
It's 20 minutes.
20 minutes. Okay.
And they're never written to disk anywhere.
And the private key is never written to disk. It sits in memory. It's used to sign it, and then it's thrown away. So never hits disk, and then a whole bunch of information is then included into the certificate. So if we scroll down a little bit, we'll see John's email, and it was verified through the Google flow. So you can see accounts.google.com and John's email there. And so this is him signing it using the human three-leg OpenID flow. Obviously the workload-based signature we showed before on I don't know if we showed distrolist, but we showed it for Cosign. It signed it as a service account. So there's another flow that you can use for workloads, and we can show some examples of that next, I guess.
Cool. Yeah, and there's one question about Connoisseur using Cosign.
Oh, yeah, Connoisseur. So I don't know a lot of the details about Connoisseur specifically, other than it's an admission controller. And what is Connoisseur? So it lists Sigstore Cosign under what it aims to support. So I don't know specifically the state of the integration there, but I do know that there's a few different admission controllers that folks have been using to do verification of cosign signatures with. I am pretty sure that you can use OPA Gatekeeper to do signature verification of cosign signatures. Kyverno has support for a variety of cosign signatures, attestations, and SBOMs, I believe. And there's also a sort of there's what we call cosigned, which is an admission controller that lives in the cosign repo itself. We're engineers; we're terrible at naming.
I think Connoisseur is actually basically attempting to be the same thing as cosigned, except it also supports Notary v1 and v2 as planned, but internally it's using cosigned.
Yeah, and there was a deeper dive on Connoisseur in a general sense. I don't think it was specific to cosign 2 weeks ago on TGIK. I think it was the week we had 2 episodes though. So rather than being 177, I think it's actually 176 because it was the morning time on that Friday. So we'll put a link to that in the notes afterwards.
Yeah, so it lists Notary v2 as planned, but there's no comment next to the Sigstore. So it looks like it should support it, but I don't know the details of that. Yeah.
Yeah, and actually, maybe we can take this is going to be a selfish indulgence for myself. I want to take a look at the cosigned real quick here. If we look, it's in package, or is it in?
You're looking for the cosigned webhook?
Yeah, there was.
So I think cosigned webhook is where the binary entry point is. CMD cosigned webhook. But the bulk of the logic is in somewhere buried under PKG. So there's 2 webhooks that the cosigned binary runs. It runs a mutating webhook that resolves tags to digests. And so even if you pass tag references to your deployments or your stateful sets or your pods, it resolves them to a digest. And then what it verifies is that digest is signed. And part of the reason it does that is if it verifies what your tag currently points to and lets it through, the pod that spins up could pull that tag, and that tag might point to something completely different. Or, one of the things that I love to hate on in Kubernetes is pull policies, because as someone who spent a bunch of time in registries, every time pull policy did the wrong thing, it wasn't Kubernetes' fault. Kubernetes could do no wrong. It was my fault. Like, why are you serving me stale images? No. Kubernetes is doing this weird thing where it does bad caching. So, in fact, my favorite story there, to digress a little bit, I guess it's a tangent, so it fits with the whole cosine trigonometry puns. But my favorite example was there's someone who came to me and they were like, Matt, I'm so confused. I deleted this image from, I deleted all my deployments. I deleted the images from the registry. I deleted it from my local Docker thing. And yet, if I apply this Kubernetes manifest, my app still deploys. How is it getting the image? Why are you serving the image? Is this an eventual consistency thing? And I was like, no, the kubelet still has your image sitting around and it's not deleting it. And there's no mechanisms for, it to know really that this thing has gone away. And because it wasn't doing pull always, it wasn't getting the 404 from the registry being like, this doesn't exist anymore. And it was just like, yeah, I got it. We're cool. And spinning up the app. This person was so confused. Smart people getting very confused by this sort of stale caching behavior. So I love to hate on image pull policy as one of those things that if digests had existed in Docker v1, we might have been able to have a better answer to early on in Kubernetes. But
But meanwhile, didn't you implement something to abuse that and pre-warm the caches on all of the clusters as well?
So yeah, that was not poll policy based, but yeah. So I wrote something called warm image that basically it basically would pre-pull images to every node in your cluster so that you wouldn't pay poll latency spinning up images. Please don't run it. I haven't touched it in years. It probably has, it's written in Go, but it probably has the log4j vulnerability somewhere in there.
It's running in production somewhere, you know it is.
Every so often, someone finds one of these little repos where I did something, and there's like awesome Go Twitter thing, and someone's like, "Hey Matt, did you see this? One of your repos is on here." I go and I reply like, "Please don't use this." Yeah. So that one's come across one of those things a couple times. But yeah, if you're interested in that kind of thing, I'm happy to talk about it. But use it at your own risk. I don't pay attention to it really at all.
So the thing I wanted to, my tangent here that I ask you about is how many different Knative imports are in this webhook, and maybe to contrast this, what would the equivalent version of building this webhook look like if you weren't using Knative? How much more code would it be, or boilerplate?
So what this is. So we have a whole other reconciler framework that we've actually talked about on TGIK a long time ago. The short story is there's a bunch of mechanisms to help just write the framework for getting the hook installed. But we also do certificate management for registering the hook to the API server, so we don't need cert manager. And that's really the huge benefit here, is that there's just not another operator doing the cert management, because it's not that much code, and there's other mechanisms that we wrote in Knative to help register resources to methods that do validation, mutating, and admission control. So it shortens up the code by probably a couple thousand lines and an extra operator.
Yeah, so I mean, we developed a whole lot of facilities like that. So we sort of built our controllers the hard way back when, the best example of how to get started was Kate's sample controller, which, there's so many things in there that are like, cautionary tales. But yeah, so basically over the years, as we sort of ran into things, we, refined our own best practices and built the facilities we needed for things. So like we use the admission control, the admission webhooks, both mutating and validating, to do our own like smart defaulting and smart validation. Since this is dating back to webhooks barely being beta, right, in Kubernetes, right? At one point we were like, well, CRDs don't support bumping generation, so we had like our webhooks use. We had a spec.generation field, and we had our webhooks bouncing some of these things. Yeah, we developed a bunch of conventions specifically around like defaulting. You can see the resource semantics, defaulting, and validation. We're sort of abusing those a little bit to do some of the checking and tag resolution here. But basically, defaulting allows you to mutate things, and really all you have to do to get support for the webhook to do this, if you scroll down a little bit, so there are these types. So you can see we're pointing apps v1 scheme group version with kind replica set at this duck v1 with pod thing, and we're actually using with pod for all of them. So basically, we have this map from like the types to a thing that implements some functionality. So that type implements two methods, one for defaulting, one for validation. It's basically set defaults and then validate, I believe. And so basically by implementing those, you can use them with our webhook, and like this is the extent of what you actually have to write yourself. And then, it handles stuff like creating a patch for you to return as part of the mutating webhook response, or, creating the appropriate, admission response when, you return an error from the validate method.
Yeah.
So it tries to make that easy. So we are actually leveraging duck typing here a little bit because, you can see we're using that duck v1 with pod for all of the different sort of apps resources, replica set, deployment, stateful set, daemon set, job. So Scott talked about duck typing on a previous TGIK, but basically these all have a sort of shared common shape with, spec.template.spec.init containers or spec.template.spec.containers. And so you don't need to know the full schema of a deployment to extract those bits and do things like tag to digest resolution, or even the limited validation we're doing. We just need to be able to extract those image references and then either resolve them in the mutating webhook or validate them in the validating webhook. And so the duck typing stuff makes this fun and easy. And yeah.
Cool. Thanks for all that background.
It's a funny question to ask how much more code would be added. I think the answer is a lot.
A lot.
The first version of it was using some of the controller runtime stuff, I believe. But it also depended on stuff like cert manager and stuff like that. But things like duck typing, which grew up in Knative, our controller framework is more or less built to enable us to support things like that. So we know what things to utilize in order to support some of the things we're doing.
Would generics simplify?
Yes, generics would. Generics would simplify the Kubernetes client stuff tremendously.
Yeah.
The whole need for code gen in Kubernetes, client Go, as well as downstream controller stuff, I would say the vast majority of it would. A lot of it would go away.
It's not exactly, because a lot of the duck typing code is not going to be solved by generics in the generic way that we're trying to do it. Anyway, that's a whole bike shed thing.
I would say a lot of the code gen would go away. But it's anyway, not Knative TGIK or duck typing or reconciler stuff. So enough of that. I'm wearing my Knative jacket though.
So we have a log index now, and I think we can look this up in the log, right? If I have the rekor CLI, or if I get the rekor CLI.
Yeah, I think so.
Is that worth trying to look at? I mean, maybe one of the things.
Let's look at it. We're exiting the territory that I do on my on a daily basis.
Yeah, I think one of the things I'm curious about, or that comes up frequently at least, is the idea of, we talked a little bit about impersonating. Like, could somebody have intercepted this this challenge and then tried to sign things as me? And this is a more general thing with keyless as well. You don't have those keys. How do you rotate the keys? Like, what does that mean? Like, you don't have to rotate the keys because you can't have access to the keys, but what happens when someone compromises your account, right? Like, you move the compromise from one place of the key to a different place, which is the account. And how do we think about that and process that in the world of keyless signing?
Yeah, I mean, I think so part of I think wanting to get to a world where we're predominantly dealing with short-lived keys, and the same goes for short-lived credentials. Although I think it's worse with signing keys, is revocation is hard, and I think this is one of the lessons that was learned the hard way over many years with the web and TLS. Is revocation is really hard. Once you've issued something, it's hard to take back. And so that's why I think there's been this bias towards, shorter and shorter lived things that, you provision through automation and whatnot. So,
and strong authentication, right? Like 3-factor auth and things like that.
Yeah. So basically using things like short-lived credentials enables you to sort of minimize your window of sort of compromise. I think beyond that, it becomes an exercise in policy, right? So if my identity was compromised for a particular window of time, right, that's you can't trust me for that window of time. Anything I sign for that window of time is potentially suspect. And so I think that's another interesting thing, right? Like we talked about the key pair being short-lived. It's good for, I think Scott said, 20 minutes. So that doesn't mean that the thing we signed is only good for 20 minutes. What is important to recognize is that one of the aspects that makes this work is we rely on various timestamping standards and third-party timestamping services and things like that to include information about when the keyless signing happened in a verifiable way. So you can basically check that during the brief window that certificate was valid. That's when the signature actually happened. So there is strong timestamp information associated with the signing that happened as well. So you can use that to invalidate signatures by me during, maybe I was under duress for, last week. And you can't trust, the things I was signing.
Yeah, and I think there's Santiago Torres, who was big, working a lot with, he was at NYU and he's at Purdue now. I think he has some grad students who are working on Rekor Watcher, kind of look at like how to establish policy and things like that, and understand like just because you have the transparency log, you still need to establish trust of the thing you're using. So I think, let me.
Should we try and sign with some more stuff? Oh, so try rekor-CLI.
So now I think we've got.
I think it's rekor-CLI. Sorry, it's.
Oh, I didn't rename it when I moved it. Aha. What could go wrong?
Don't forget sudo.
So now, cannot, developer cannot be verified. All right, we know how to resolve this, right? We just allow it in our security. Don't try this at home. Is this the right general?
I'm just looking to see if there's a way to install this with brew.
Oh, did I not?
Maybe try. Oh, you can say brew tap Sigstore/tap, and then you should be able to install rekor-CLI, maybe. Or you could say brew install Sigstore/tap/rekor/CLI, maybe.
We've got the tap now, so I think maybe this will.
Yeah, all right. That looks like it's doing something.
Ah, yes. Now we need to overwrite. Let's get rid of that terrible downloaded one. And, run brew link. It's already there. It's just.
All right.
All right. So now we should be able to get, do we need just a log index? And if we haven't lost, there we go.
Are there other options? What say like dash help or something? Help, log index, format. So that's fun.
Yeah, maybe we will need to do another TGIK with Luke. We'll do a EMEA timed one so we can have Luke on. Yeah, we're already at an hour and a half. Did you want to try signing a few other things? There's.
I mean, we don't necessarily have to run through it. There's, we've been. I've been trying to write little blog posts on the ChainGuard site showing how to do as easy as possible. I call it zero friction. So signing different ways with workload identities and key lists. So there's one from a week or two ago about using GitHub Actions, OIDC to sign things. There's also one that talks about using Kubernetes service account token projected volumes to sign things on. The examples are in EKS. It also works with GKE, and I think it's coming soon to an Azure cluster near you, but it's not quite there yet. And you can also on GKE use GKE workload identity to sign things. We don't have a blog post about GKE workload identity, but yeah, there's a whole bunch of different ways of signing things. And we've, I think, barely scratched the surface. We only did some things with, signing with keys, without keys. You can also start to do things like Cosign attest, where you start to do attestations and claims instead of just signatures to attach, to make what you're signing some sort of claim as opposed to, just the naked signature. You can use Cosign to attach and download SBOMs, and some of the support for that, support for SBOMs, is starting to work its way into tools like, I believe the build packs has added support for SBOMs. Co has support for SBOMs. So if you're building things with those, you can say, Cosign download SBOM and get the SBOMs associated with some of these things. So there's a lot more there. I think we've barely scratched the surface. But if we gotta go, we gotta go.
Well, we have an excuse to bring everybody back and to talk about this more in the future. So,
hopefully there was a lot of background and framing of why Sigstore.
Yeah, so everyone's just got to watch this before, we come back and, at chipmunk speed, so I'll be talking.
Yeah. Anything else you want to chat about today before we?
No, my brain's been shutting down for the rest of the year over the last week or so. So, it's Friday before, I'll be around Monday and Tuesday, but I don't know if my brain will be. But yeah, it's been slowly checking out.
Yeah, that's same. This is the only thing standing between me and the end of my work here. So and you can see it's starting to get dark around me as well, Central Time, and in northern Minnesota. So it's getting dark out at 4:30 for me. So it's about time to call it a wrap. And I appreciate everybody joining. I appreciate all of you who will watch this on demand later. And very much thank you to Matt and Scott for joining, and I would love to continue this conversation further. I think there was some conversation about doing a Twitter space about Project Sigstore at some time in the near future. So
yeah, I think that'll probably end up being next year, given that we didn't make it happen this week. I think the consensus is that will probably happen via the Project Sigstore project Twitter account, and so we've got to figure out how to set that up and moderate. But if you follow that on Twitter, we'll try and socialize that happening well in advance. So you can click the little set reminder thing if you're interested in tuning into that.
Yeah. I think it'd be really cool if we did like a series talking with like focused on a language per session or something, or a package manager, and like see if we can kind of get the community roused to sign things.
Yeah, I think we could, based on how far we got today, we could have a TGI SSSC. What do you think? That might be too much for everybody. I don't know how many viewers we'll get, so we'll see. Maybe they'll have me back. We'll find out.
All right. Thanks for everyone for tuning in. Thanks
everybody.